Okay, today we're going to talk about scientific notation. Now, this is a review from pre-algebra, or it should be, so I'm going to go pretty quick on the basics, and then I'll slow down when we get to the harder stuff. All right, so express 0.000033 in scientific notation. Now, one thing that you should remember about scientific notation is only one number between 1 and 9 can go in front of the decimal. So that means that in this problem, I need to move the decimal 1, 2, 3, 4, 5 places. So I should get 3.3 times 10 to the fifth because I moved the decimal 5 places. That's it. In number 2, we're going to express 0.034 times 10 to the seventh in scientific notation. There's two ways that you can do this. I'll show you both. So the first way that you're probably used to is you write the number down, and you're going to move the decimal 7 places. Okay, so you're going to go 1, 2, 3, 4, 5, 6, 7. And you would fill those in with zeros. So you would end up getting 340,000. But you know you can only have one number in front of the decimal. So you need to go back over 1, 2, 3, 4, 5 decimal places. So you get 3.4 times 10 to the fifth. So that's the way that you're used to doing it in pre-algebra, which is the correct answer. But today I want to show you how to do it a little advanced. Okay, so we're going to take the same problem, 0.034 times 10 to the seventh. You know that this only cuts out, it does cut out some steps because you know that you only need to go to the 3. So watch, you're only moving 1, 2 places so that you can have 3.4. So this is the way that I think about it. I'm going from a small number, 0.034, to a larger number, right? So if my base number is getting bigger, my exponent needs to get smaller. So I'm going to say -2 because I moved 2 decimal places. So this would be times 10 to the fifth. So if your base number gets bigger, your exponent needs to get smaller. If your base number gets smaller, your exponent gets bigger. It's a balance. Number 3, we have evaluate 3.2 times 10 to the negative fifth times 5.4 times 10 to the ninth and express the result in scientific notation. So when we do this, we are going to multiply our base numbers. So you're going to say 3.2 times 5.4. And when you do that, you get 17.28. Now, you should remember from monomials, when you're multiplying, you add your exponents. So this would be the base numbers, right? And your exponents, you would actually add those. So -5 plus 9 is 4. So we would say times 10 to the fourth. But you can't have two numbers in front of your decimal places. So this is not allowed. So we need to move this over 1 decimal place. So I should get 1.728. Now, my base number is going from 17 to 1. So since this is going down or getting smaller, my exponent needs to get bigger. So I moved this 1 decimal place, so I'm going to add 1 here. So I get times 10 to the fifth. And that's how you do it. Number 4, what is the value of 4.4 times 10 to the ninth times 3 times 10 to the negative fifth? Same thing, so we're multiplying. So we're going to go 4.4 times 3. When I do that, I get 13.2. And then 9 plus -5 would be the same as 9 minus 5, which is 4. So times 10 to the fourth. But again, you can't have this. So you have to move 1 decimal place because only one number can go in front of the decimal. So if my base number is getting smaller, my exponent has to get bigger. by however many times I move the decimal. So my answer would be 1.32 times 10 to the 5th. Number 5, I have expressed the result of 2.345 times 10 to the 6th divided by 6.83 times 10 to the 3rd in scientific notation. So we're dividing, right? So we're going to divide our base numbers and we're going to subtract our exponents. So really you're going to go, oops, sorry, hold on. You're going to go 2.345 then divided by 6.83, and it's got decimals, so you can use your calculator. When you do that, you get 0.343. You can put 0.343. And then you're subtracting your exponents, right? Because you're dividing. So 6 minus 3 is 3. So I'm going to put times 10 to the 3rd. However, you need one number between 1 and 9 in front of the decimal place. So I'm going to have to move this decimal right there. Make that 3.43. Now, I made this number from a 0 to a 3, so this one my base number got bigger, so I need to make my exponent smaller. Remember, it's that balance. And since I moved it one decimal place, I'm going to subtract 1 and say it's 3.43 times 10 squared. Okay, last problem. Evaluate and express the result in scientific notation. So, what I'm going to do is we are, this is the power of a power, right? So I'm going to say 3.16 squared, which is 9.9856. Okay, and then what do we do with the power of power? We multiply it. So negative 2 times 2 is negative 4. So this is going to be times 10 to the negative 4. And that is my answer. Now, if I also wanted to, so this is in scientific notation. How would I, if I wanted to, how would I express that in standard notation? So standard notation is a regular number. If I wanted to, so I'm going to put standard so that you'll know that this is a standard number, okay? So I'm going to go, well, let me write the original number first. So 9.9856 times 10 to the negative 4th. So since this is negative, I'm going to move the decimal. So 1, 2, 3, 4. Put your zeros. So standard form would be 1, 2, 3 zeros, and then the number. So that would be the answer in standard form if we wanted to do that. This last problem has a lot of decimals and it's a fraction, so I just wanted to do one more with you. So again, we're dividing. So I've got 1.032 divided by 8.6. When I do that, I get 0.12. Okay. Now again, we're dividing. So what do we do with our exponents when we divide? We subtract. So negative 4 minus a negative 5. That double negative becomes plus. So that would just be 1. So we've got times 10 to the 1. So that is not in scientific notation. A lot of students stop there and they say, okay, I'm done. You're not. Why? Because this number right there is not between 1 and 9. So we have to move the decimal point over. So we get 1.2 times 10 to the what? Well, I made this number bigger, right? So I need to make my exponent smaller. And I move my decimal place one time, so I'm going to subtract 1. So 1 minus 1 is 0. I know that's odd looking to have something with a 0 power, but it still needs to be in scientific notation, so it still needs to be in that form. Now, so that is the answer, 1.2 times 10 to the 0. That is in scientific notation. Now, if I wanted to write that in standard form, what is anything to the 0 power? It's 1, so the answer in standard form would be just 1.2 by itself.